Chaining PyQGIS process, a step-by-step guide. Hello guys, in this tutorial you will explore how to chain process in PyQGIS using real-world data from the governorate of Erbil in Iraq. By the end of this guide, you will have a solid understanding of how to chain multiple geoprocessing tasks in PyQGIS and apply this knowledge to your own projects. We will cover selecting primary roads, creating buffers, reprojecting, finding places along those roads, and printing their names. The dataset for this tutorial can be downloaded from Python PyQGIS repository in my GitHub Azad77. We use places and roads shapefiles. Step 1. Loading the data. First, we need to load the shapefiles of roads and places from the city of Erbil. Define the path to shapefiles. For example, ROA equal my path and shapefile is roads.shp and PLA for places.shp. Then load the roads and places layers. Road layer equal QGIS vector layer ROA, comma, the name in the QGIS panel, roads original data, OGR for dealing with the shapefiles. Places layer equal QGIS vector layer PLA, places original data, and comma QGR. Check if the layers were loaded successfully. If not, roads underscore layer is valid or not. Places layer dot is valid. Print error, one or more layers failed to load. Else, QGIS project dot instance dot added map layer, the first layer, road layer, and QGIS project dot instance added map layer, places layer. Step 2. Reprojecting the roads layer. To ensure accurate distance calculations, we reproject the roads layer to a projected CRS. For example, UTM zone 38N for Erbil. Reprojected roads equal processing.run native colon reproject layer. Input is roads layer. Target CRS is EPSG 32skis38. Output memory. Then added the reprojected roads layer to the map. Reprojected underscore roads dot set name. Roads reprojected to UTM zone 38N. QGIS project dot instance dot edit map layer reprojected roads. Step 3. Selecting primary roads. Next, we filter out only the primary roads from the reprojected roads layer using an expression. Define the expression to select primary roads. Expression equal F class. The class type equal primary. Then use the native colon extract by expression algorithm to filter primary roads. Primary roads equal processing.run native colon extract by expression input projected roads expression primary from the F classes, and the output is memory. Then added the primary roads layer to the map. primary roads dot set name, primary roads filtered from reprojected roads, QGIS project dot instance dot added map layer primary roads. Step 4, creating buffers around primary roads. Now we create a buffer around the primary roads. Buffers are useful for finding features within a certain distance of their features. Define the buffer parameters. Buffer distance equal 100, for example, a buffer distance in meters. Segment equal 5, number of segments to approximate a circle. End cap style equal O, round end cap style. Join style equal O, round join style. Meter limit equal 2, meter limit for sharp corners. Dissolve equal false. Do not dissolve buffers. Use the native colon buffer algorithm to create buffers. Buffered primary roads equal processing.run native colon buffer input primary roads distance segment and output is memory. Added the buffered primary roads layer to the map. Buffered primary roads dot set name buffered primary roads 100 meter buffer. QGIS project dot instance dot added map layer. Use the output of buffered primary roads. Step 5, reprojecting the places layer. To ensure spatial consistency, we reproject the places layer to match the CRS of the buffered primary roads. Reprojected places equal processing.run native reprojected layer input places layer target CRS from CRS of buffered primary roads output memory. Step 6, finding places along the primary roads. With the buffers in place, we can now find places that are located along the primary roads. We use the native extract by location algorithm to find places within the buffers. Place along primary roads equal processing.run native extract by location input reprojected places predicate O intersect buffered primary roads output memory. Then added the place along primary roads layer to the map. Place along primary roads dot set name. Place along primary roads within 100 buffer. QGIS project dot instance dot added map layer. Use place along primary roads. Next step, printing the names of place along primary roads. We print the names of the places that are located along the primary roads. Iterate through the features in the place layer and print their names. Print place along primary roads. For feature in place along primary roads dot get features. Print feature name. Then calculate the total length of primary roads in kilometers. Total length equal O for feature in primary roads dot get feature. Total length plus equal feature dot geometry dot length. Total length in kilometer equal total length divided by 1000. Changing from meter to kilometer. Print f string total length of primary roads equal total length kilometers. To count the number of places along primary roads, we use num place equal place along primary roads dot feature count. Print if number of places along primary roads equal num places. In the next step, export the buffered primary roads to a new shapefile using buffered output path equal my path. We name it buffered primary roads.shp. QGIS vector file write as vector format and buffered output path UTF-8 buffered primary roads.crs. The projection, the type is the shapefile. Print if buffered primary road is exported to the path. In the same way, export the place along primary roads to a new shapefile. Place output path. We name it place along primary roads.shp. QGIS vector file write as vector format. The file is place along primary roads. The output path UTF-8 and the projection from place along primary roads. The type is the shapefile. Print place along primary roads exported to the path. We can customize the symbology of the buffered primary roads layer. Buffer symbol equal QGIS field symbol. Create simple color and outline. Buffered primary roads dot render dot set symbol buffer symbol. Then trigger repaint. In the same way, customize the symbology of the place along the primary roads layer. Use the places symbol. QGIS field symbol dot create simple. For example, color red, outline black, outline width 0.5. Place along primary roads dot render dot set symbol. Use the defined place symbol. Then trigger repaint. We copy the code and go to QGIS. Inside the Python, we open new editor. Ctrl V to paste the code. Then run the script. In just seconds, all process runs and the output is we have roads reproject to ATM zone. Then primary roads. We have buffered primary roads 100 meter buffer. We can change it to 500 and so on. Then place along primary roads within 100 meter buffer. And also in output, we have placed along primary roads. For example, Shaklawa, Golak, Shamshula, Majidawa. Total length of primary roads 771 kilometers. Number of places along primary roads 7. Buffered primary roads exported to this path with the name buffered primary roads.shp and place along primary roads exported to this path, and with the name of shapefile places along primary roads.shp. Conclusion. In this tutorial, we walked through the process of chaining multiple PyQGIS process to analyze spatial data. We started by loading data, reprojecting layers, selecting primary roads, creating buffers, finding place along those roads, and printing their names. We also explored additional examples and applications to extend the functionality of the script. By mastering these techniques, you can automate complex geoprocessing tasks and apply them to your own projects. Whether you are working with urban planning, environmental analysis, or any other field that involves spatial data, PyQGIS offers powerful tools to streamline your workflow. Feel free to experiment with the code and adapt it to your specific needs. Happy coding!